Hey calculus friends, this is my last video with derivatives and function graphs. So make sure that you've watched them all and you understand them, because I'm going to post some homework later today. Alright, so this time we're going to go from the function graph to the derivative graph. Okay, so the last time we went the other way. So this time we're going to go from function to derivative. Okay, so remember the derivative is the slope of the tangent line. The slope of the tangent line. Notice here at this function right there, that tangent line, the slope is 0. So I know when x is 1, the slope is 0. So I know that it has to cross the x-axis at 1. Okay? Now I'm going to look at the edges here. So I have if I draw that tangent line, which is not a very good tangent line, but pretend it's tangent, it looks like it's positive, and it looks like it's pretty large, positive. And then as I get closer here, this still positive, but not so steep, so it's getting smaller positive. And as I come in here, it's getting smaller positive. So I have to come in with some sort of straight line. I don't know exactly where that straight line is going to be, but somewhere with the straight line. Now as I go this way, it's starting to be negative, and then when I get down here, it's super negative. So I'm just going to continue this, and I'm going to draw it like this, and I ask myself, does that make sense? And I say to myself, yes, because this is like a quadratic, y equals x squared, and the derivative would be a line, like 2x, right? So the derivative, if that were plain x squared, which it's not, it's actually a negative x squared because it's upside down, then my derivative would be like a negative 2x. And notice the slope of this line is negative 2 everywhere. So that sort of kind of makes sense. So that's a good thing, and that makes sense to my brain. So I'm like, okay, I'm good with that. All right, so now here's the next one. This one has two places where the derivative is 0. Here, when x is negative 1, and here, when x is 0. Those are the two places that my derivative is 0. Okay, so I'm going to go ahead and mark those two spots because I already know that that's where it's going to be 0. All right, so now I start on the left here, and I'm drawing a tangent line, and I say, that is a negative, very negative slope. It's very negative, so I'm going to start down here in the very negative slopes. Then it becomes less negative as I keep going up, so this is going to be less negative, so that's going to be like that. And then here, this little bit in here, this is all positive slope. Okay, so it's all positive, but it's got to come back down to 0. So I'm going to go up a little bit and then come back down to 0. Because this is a cube, right? Y equals x cubed. So I know that this has to be a square, y equals x squared kind of thing. So I know I'm looking for a parabola. And then I look at this and I say, oh, all of these slopes are negative. So all of these slopes are negative. So it's going to go down like that. All right, so it's kind of a bad graph, but there you go. All right, and the last one is still a cubic, and so I have to get a quadratic, but notice this time this side starts positive. So it's going to start, oh, let's go this way. Sorry, let's start with that. 0 and 0. So 0 at negative 2 and 0 at 1. Okay, so now I look at this back over here again. This is a positive slope, but it's very positive. So very positive, and then it's going to get to 0, so it's going to cross at 0. And now this is all negative over here. You can see me drawing that in. It's all negative there. So it's going to go negative, and then it's going to come back to the negative 1, and now this side over here is positive, so it's going to become positive over here. So again, my cubic becomes a quadratic.